Hey guys, so I wanted to give us a review on the characteristics of quadratic functions because this is the main meat of our test that is coming up. So when you are given a graph and they ask you to find the vertex, this is your max or min point. And so if you look at your graph, your maximum point is going to be right here. And it's going to be -3, 8. Alright, and your axis of symmetry is always going to be the x-coordinate of the vertex. Oops, let's do this. And what's our x of our vertex? Well, it's -3. So our vertex is, our axis of symmetry is going to be x equals -3. And then if you look at your graph, look at which way your arrows are pointed. If your arrows are pointed down, then it opens down. Alright, and check out where your vertex is. Okay, if your vertex is the highest point, then you have a maximum. And it's going to be the y of the vertex. So y equals 8. Because if you look up and down, the highest point is at 8. Alright, your roots are going to be your x-intercepts. And so that's going to be here and here. So x equals -5 and -1. Your domain is always all real numbers. And your range, you go bottom to top, remember? So what's at the bottom of our graph here? Well, those are arrows. So that means that we continue to go down, 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 down. So that means that we're going to start at -infinity, and then we're going to go all the way up, and our highest point is our y-coordinate of our vertex. So that's going to be 8. And remember, because it's an exact point on our graph, we get to make the bracket. Now, where a function is increasing, so we're going to take a look at our graph. And we're going to go left to right, all right? So, from the left means what? Left means -infinity, because as we continue to go, we're going more and more negative. So, if we're starting from the left and we're going up, that means we're starting from -infinity. And then we continue to go right, and we stop increasing at this point here, our axis of symmetry. Okay, and so we stop increasing at -3. And then we begin decreasing at -3, and we continue until, because we continue to go right, we're going to continue until positive infinity. Alrighty, and then finally, in behavior, look at your arrows. And remember that this must be the same answer. Alright, so if both of our arrows are pointed down, we're going to -infinity. Alrighty? Okay, cool. So now, let's do the next one. Actually, I'm going to let you guys do this one. Number 2 is going to be your assignment. Okay? We're going to do number 3 together. So, for this one, we are given an equation, and we must answer the following questions about it. Okay, I'm sorry it's slanty, and that's a little bit better. Not much. Alrighty. So, first, you have to decide which form this is in. This is an intercept form. Whenever we have 2 parentheses, it's intercept. Alrighty, so when we're in intercept form, in order to find our vertex is going to be p plus q divided by 2. Now remember, our p and q are the opposite numbers, the opposite signs inside our parentheses. So if I have a +3, that's going to become a -3. And if I have a -1, that's going to become a +1. over 2. So negative 3 plus 1 will give us negative 2 over 2, which gives us negative 1. Okay? And hey, look, this is actually our axis of symmetry. So x equals negative 1. To find our vertex, we have to substitute our axis of symmetry back into our equation. So for our vertex, we're going to do negative 1 plus 3, and then times negative 1 minus 1. So that's going to give us 2 times negative 2, which is going to equal negative 4. And this is our y of vertex. So then our actual vertex is going to be negative 1, which we got from our axis of symmetry, the p plus q divided by 2, and then comma, the negative 4. All right, and then we can go ahead and graph that along with our axis of symmetry, because if it asks you to graph, you got to graph all these fun things. Alrighty, so now that we have that, this is where we use our handy dandy calculator. Alright, and I will give you guys a link for our calculator online. So you are going to go to table, and you're going to type in this equation exactly as you see it. Let's see, x plus 3, x minus 1, and then we're going to start at our vertex. We need to start at negative 1. Make sure that this is our actual vertex by making sure that the numbers surrounding our vertex are the exact same number, which they are. So we have negative 2, negative 3, and we have 0, negative 3, and then I have 1, 0, which makes sense, and we have negative 3, 0. So why does it make sense that this point is 1, 0 and this point is negative 3, 0? Well, from our our intercept form, we can go ahead and tell where our graph crosses the x-axis at negative 3 because we just changed the signs. 3, negative 3, negative 1, positive 1. So that's what the intercept form does for us. Alrighty, and now that we have our 5 points, we can go ahead and connect our dots, and we can answer the following questions. So now, does it open up or down? Well, our arrows are pointed up, so it's going to open up. And do we have a max or a min? This time we have a minimum because we have a minimum point. All right, and our minimum point is going to be our y value of y equals negative 4. And then our roots are our x-intercepts. And so that's going to be x equals negative 3 and positive 1, which we also got from our equation. Our domain is always, always, always all real numbers. Our range, bottom to top. So at the bottom of this graph is negative 4. And then we continue to go up, 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 and we hit an arrow. So that's going to be positive infinity. And then our function where our interval is increasing and decreasing, well, let's start from the left. So remember, from the left is negative infinity. Alrighty? And from the left, we're going down. So decreasing is going to be negative infinity. And we stop decreasing at negative 1. Because remember, we're looking at our x values. Therefore, we start increasing at negative 1, and we go all the way to positive infinity. And then our end behavior, check out where your arrows are pointed. Since they are pointed up, both of our answers would be positive infinity. This piece right here got cut off, but that's what that means. Alrighty. So if you had problems with number 2, hopefully this one will help because it's the same shape of graph, and hopefully that'll help you. All right, moving on to number 4. Alrighty, so check out which form this is in. If it has 1 parentheses, that means that this is in vertex form. And hey, look, both of these are in vertex form. So I'm going to do 4 and you guys are going to do 5. Alrighty. So the great thing about vertex form is that inside our equation, it automatically tells us what our vertex is. So if we remember our form, this is our H and this is our K. Excuse me, I'm about to sneeze. Excuse me. Alright, but the tricky thing is that our H lies. So when we put in our vertex, this says -4, but because H lies, this is actually going to be a +4. And then our K remains the same. So our vertex is going to be 4, 2, which we can go ahead and graph. And then our axis of symmetry is x equals 4, because it's always the x-coordinate of our vertex. Alright, and so now we can go back to our calculator and we are going to type in our equation exactly as we see it. Okay, we're going to start at our vertex, and hey, look at that. Cool. Now, 5/2, that's kind of scary. Can you guys see that? Let's make sure. Alright, I think you guys can. Let's see. So that, just change it to a decimal using this button and it becomes 2.5. So we have 3, 2.5. So 3 and then 2.5 is about right here. And then we also have 5, 2.5. And then we have 2, 4, which means that we're going to have 6, 4. And then we have our points, so we can make our graph. This one's a little bit wider. Cool. Alrighty. So now, does it open up or down? Well, look at your arrows. It opens up. Do you have a max or a min? You have a minimum. What's your minimum value? It's going to be 2, because it's always the y-coordinate of your vertex. Do we have any roots? Nope, because it does not cross this line right here, your x-axis, we have no roots. Domain, as always, all real numbers. Your range, bottom to top. So from our bottom, we get 2. And then our top, we go all the way up to positive infinity. Alright, start from the left, because the left is negative infinity, the right is positive infinity. Okay, so what are we doing over here? We're decreasing. So that means at decreasing, we're going to put negative infinity, and it stops decreasing at 4. Therefore, we start increasing at 4, and we continue to increase all the way to positive infinity. Alright, and then finally, in behavior, are we going up or down? We're going up. So, both of our answers are going to be positive infinity. Very good. So now you guys can do 5, because it's the exact same type of problem. Alrighty. If you get stuck on what you do after you graph it, look at number 1. That should help you. Alright, and finally, I'm going to do 6, y'all are going to do 7. If there are no parentheses, this means that we are in standard form. Alrighty, so when we are in standard form, we have to find our axis of symmetry first. And to find our axis of symmetry, this is going to be the negative b over 2 times a. So you might want to list out what your a, b, and c are. So our a is 1, our b is 6, and our c is negative 8. So I'm going to have negative b, which is 6, over 2 times our a, which is 1. So that's going to give us negative 6 over 2, which is going to give us negative 3. And then we are going to go to our table, and we're going to type in our equation. oops, not that, x squared plus 6x minus 8. And we're going to enter, and we're going to start at -3 because that's supposedly our vertex. And then we're going to check it. Excellent. So I get -3, -17, which is surrounded by the -16s. So -3, -16. But wait a second, Miss Johnson, that's not on our graph. Well, that's okay. It doesn't have to be. Just start moving up and down until you find a number that is on your graph, like 0, -8. So 0, -8, and then 1, -1, 2, 8, okay, and then go all the way back. Let's see, whoops, I went too far. Okay, so our vertex was -3, 17, so I'm going backwards, and I get -6, -8, which is right here. And then I get -7, -1, and then it should be -8, 8. And so this time, the way that we draw this, oops, it looks like my pen is about to die. Because our vertex isn't on our graph, we're going to draw it something like that. And make sure that you do draw your axis of symmetry. Okay, ta-da. But that's all that you really need for this graph. Okay. Alright, so tell me, does it open up or down? Well, look at your arrows. Where are they pointed? They're pointed up. So, we open up. Do we have a max or a minimum? Well, because our shape looks like this, even though we can't really see it, we're going to have a minimum. And that minimum value is going to be the y-coordinate of our vertex. Whoops. So y equals -16. Do we have any roots? We do, but because they're not perfect, don't worry about this section, okay? They're too difficult. Alrighty, domain is going to be all real numbers. Range, start at the bottom. Well, what's at the bottom? Your vertex is, okay? And because range is always our y's, we're going to start at -16. And we're going to go all the way up to positive infinity. Increasing and decreasing. Well, remember, left is negative, right is positive. So we start decreasing at negative infinity, and we continue to decrease until we hit the right side, which is -1. Or sorry, -3. Wow. And then we start increasing at -3 and continue on to positive infinity. And then finally, our end behavior, check where your arrows are. They're pointed up. So both of these are going to be positive infinity. All right, so you guys get to do 7, and this is the end of our test review. Good luck, guys.